Thank you. So I'm a principal product security leader. My job is to work with teams every day to help them make more secure product. So threat modeling is one of the things that we do regularly with them. So here I'm going to give you an introduction, and we're going to kind of go over a couple demos of basic threat modeling practices. So how many of you have heard of threat modeling? Okay, great. Most of you have. Excellent, excellent. What is threat modeling? Well, it's a variety of different things, right? It could be an analysis process. It lets you describe potential things a bad actor would do. It's a way of building a set of responses for certain personas that an attacker persona might do, right? It lets you abstract your security problems down into classes, categories, data flow objects, common things that are the same across all instances of a given object type. It lets you figure out what the issues for, say, a process are and be able to map them all together. But why should we threat model? Well, you know, breaches are way up. How many of you have heard of all the breaches in, pick an industry, right? I mean, you name it, the industries are getting whacked right now. And it's really getting to be big business from the attacker side. And if we could solve part of that at the design phase with something like threat modeling, I think it'll really help us go a long way. So if you look at some of the ones in the past, look at what happened to Target. It was such a bad problem that caused the CEO and the CIO to have to leave, right? Things like the Anthem breach, going to cost like $100 million, they estimated. Sony Pictures back in 2014, they had to deal with $35 million in IT repairs. I mean, if you get the design wrong, it costs big money to fix later on. And threat modeling can do that, right? So why should you do? Well, as we said, it identifies those problems. It gives you a way to look at the design at the design time. Helps you better understand those risks and encourage predictive and effective prevention strategies. And this graph here is a classic one. It shows how if you can find it way early, the cost to fix is going to be way lower than if you have to do it after release. Study after study in a variety of different industries has shown this, and security is no different. So threat modeling is and is not certain things. It is a way to find security threats. It's an opportunity to look through an attacker's eyes. It's a technique to eliminate some of those problems that you might find. It's one of the ways you can actually increase security awareness amongst your development staff. If they have to do a threat model, they're going to remember a lot of that training that they did. But it's not a way to fix everything. It's not about collecting artifacts just for the sake of collecting artifacts. It's not a one-time thing, right? Ideally, you build a threat model at one point, and you update it over time as that technology stack, as it ages, it grows, it changes over time. It's not a panacea. It doesn't solve all the world's problems. It only lets you try to prevent problems ahead of time. It's not just about creating a data flow diagram. Data flow diagrams are great. They're used in the threat modeling demo I'm going to show today. But they're not the end all. And it shouldn't be considered as a security tax, right? You wouldn't go through the design of something and call that a tax. That's just part of how you build it. Well, threat modeling is the same way. So who can benefit from this? Well, tablet vendors, tablet app vendors, standalone apps, SCADA systems, medical devices, workflows, business processes. You can threat model anything because fundamentally you've got a process that takes data, transfers it somewhere, that takes that data, maybe stores it, and then does something and transfers it back. You can break down anything, even a paperwork process, into those simple elements and threat model it. But let's look at it from a technology perspective, a software perspective. Well, who should be involved in those threat modeling sessions? Well, someone like a team security champion. So let me take a poll. Who has some sort of security leader, a team security champion, someone who's responsible for the security of a development group who actually sits in that particular development team? Like a localized security help? No? Okay. What about architects on that team? Developers? Everybody's got developers. Test engineers, right? you name it down this list here, these are all folks who are involved in the design and the build and the development and the creation of that software. And they're going to be the ones who are most knowledgeable about how it works, how it should work, how it's put together. They're going to be the ones that you want to have with you at that particular meeting to build the threat model, to build the data flow diagram. You might even consider bringing in teams who are working on a related dependency. So if you have the luxury of having 2 development teams in-house and they're making parts that work for one another, you can certainly bring in the team that's making the other component. There's also some additional benefits. You end up with a data flow diagram after you're done, which brings everybody on the same page with respect to architecture. I've seen it time and time again where you have teams that there's one diagram for the logical flow, there's another diagram for the physical flow, and they don't match. But if you take an amalgamation of the two as you're building a threat model, you can have everybody look at it and say, yeah, that's what we got. It also reinforces all that security training. So as you're asking people to do that secure development training once a year, and you're all training your developers on how to write secure code, right? It reinforces that. It gets them the opportunity to use that knowledge when they're thinking through, oh, that's a threat I need to deal with. Or, oh, that's how I can mitigate that particular threat. It really brings to light the threats to a system. It can also bring to light the changes of threats to a system. So take a simple example we'll talk about in a minute. When you add a node, when you add a layer to that threat model, you're actually adding threats. It also encourages the creative thinking, right? There's always somebody in the team. I liken it to the phrase from Dune, awaken the sleeper, right? You've got somebody on the team who has some security knowledge, some security smarts, some security experience, and you can really bring that knowledge to life and get them to make good use of it and really find out who's got the security smarts that you really want to make sure that you're encouraging. They're going to be your assets, your allies in that team. Well, when should you do it? Well, the simple answer is always. But think about it at different stages, right? Early on, we're talking about pre-design. Maybe you've got something that you want to do it before you actually written code, or it's just really formative stages. You can avoid vulnerabilities in the design. You might find some problems at that point you got to go fix, but it's going to become design inputs. As you do it ongoing, you can go back and revise things as they change. It'll help you make sure you're implementing the right trade-offs, the right mitigations. And then it's going to also identify newer threats as those changes get identified. And then you can do it late, and it probably should be something you do to come back around at the end to reinforce, to say, hey, yeah, we've gone back, we've made sure our threat model is still up to date. But if you're starting at the late stage, it's probably a little too late. You're probably going to have to put customers at risk. Or you might find some vulnerabilities really late in the cycle. Something that can't be patched easily or right away. So earlier is certainly better. So let's think through, I know I've gone through a lot already, but let's think through some of the best practices that we'll start to conceptualize as we're bringing together one of those threat modeling sessions. It should be a group exercise. Certainly there might be somebody most knowledgeable who's driving it from an agenda perspective. Someone with familiarity with the tool who's actually in the driver's seat of the actual tool, as I'll demo in a moment. But you want to make sure that if somebody does create it, there are other people who are going to take a look at it and review it, provide that feedback. Because that's going to build the consensus of, yeah, that's what we built. Therefore, yes, we can agree that these are the threats that we have. It could be an interactive meeting. I always prefer face-to-face or something like some sort of remote technology where everybody can see what's going on in the threat model at the same time. Don't assume that it's mitigated and disregard it. Make sure it's noted, right? We're going to record the actual note that, hey, we know this is mitigated because of X, Y, and Z. Some people might come up with some new and interesting threat or abuse case. You want to make sure you capture those. They might not come out of the tool, but they're still useful. There's still things to consider about, hey, here's how something bad could happen in our particular software product. And then just build that case, that document set as you go. Doesn't have to be perfect. Just a record of what the threats have been collected. Also want to capture dependencies, assumptions, related teams, all that kind of stuff to understand the span of control. Because when you're threat modeling, one of the trip-ups you can fall into is trying to threat model somebody else's stuff. It's useful. You want to understand what threats you might inherit from them. But you might end up spending more time threat modeling their stuff and not enough time threat modeling your own. So you really want to make sure that the span of control is clarified as part of that exercise. Any external dependencies need to be identified. You want to make sure you have owners and you wrote down who contributed, the version of the software, so you can go back and say, hey, yeah, we built this at this time for this particular release. And that gives you kind of a starting point to capture the headspace of what you were assuming at that time when you're starting to build something. So we kind of go over a high-level process, but what can you do to actually threat model? Well, first, I'm going to decompose the processes down into a data flow diagram. Because a process is effectively executable code when you think of it from a software perspective. We're going to want to identify each of these objects here, right? We're going to have processes, we have users or external entities like a foreign web service that's outside of the span of control that has to be utilized somehow. There's going to be data flows, and those are indicated by the nice little curved line there. And we're going to have to do something with that data. It's going to have to be stored somewhere, somehow, in some fashion, so we're going to mark those too. So when you put those together, what we have here is a typical web application. How many of you have actually built a web app that does this? This is the classic simple design, right? You got a browser, talks to a web server, there's some sort of administrator on the back end who does something with it, and it does something with server storage. Now, that diagram is missing a few things. It's missing trust boundaries. Somewhere to understand where an inflection point between what we can rely on and what we don't rely on, what we don't trust. We're going to put a dashed line on the diagram that will indicate, hey, over on this side, we don't trust what's coming there. So all data from outside that trust boundary should be considered radioactive until proven otherwise. So take that earlier diagram, and we'll put some trust boundaries on it. So there you can see between the administrator and the web server and between the browser and the web server, we've got some trust boundaries that indicate, hey, data on this side should not be fully trusted. Not until it's been validated, checked, tested, made sure that it's not going to cause problems in the system. Okay, so once that diagram is all put together, we can start to talk about threats. How many of you are familiar with the STRIDE acronym? Anybody? Oh, good, excellent. So you can see here, we've got different threats, and they're kind of simplified into 6 categories. Spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. And they really kind of encompass the simple technical threats that all those objects on the data flow diagram might incur. And you can think about, well, what does that mean? Well, that means for every one of those threat types, we have a desired property to counter it. So to deal with spoofing threats, maybe we need to have authentication. We need something like integrity to handle tampering. We need some sort of attribution or logging to handle the repudiation case. We want to have confidentiality to prevent information disclosure, some sort of availability control to deal with denial of service, and then maybe we need to worry about authorization. In fact, we most likely need to have authorization everywhere to deal with any sort of elevation of privilege challenges. So expanding on that, let's think of a couple examples. So for spoofing, maybe an example there would be something like someone pretending to be the CEO, or one web service pretending to be another. For something like tampering, we could have the ability to modify a packet or to modify a message to a web service. Repudiation is the one that's sometimes a little hard to contemplate. It's the ability for an attacker to say, I didn't make that, I didn't do that, and you don't have proof. Information disclosure might be something like allowing someone without any sort of authentication to be able to see something who doesn't have sufficient privilege to be able to get that data, or sometimes even subtly things like data that is just exposed as part of the metadata. You didn't intend to tell somebody about something, but that Word document has some sort of piece of data in it about who the author is that exposes something. For denial of service, you're talking about somebody who might be able to just barrage the web server, the web application with bad inputs and see how it reacts and balks and maybe crashes or whatever. And then finally, with elevation of privilege, it's say maybe the ability for someone to, on the user side, to run commands that only an administrator should be able to do. So as we're building these diagrams, we might run into some foibles. I mentioned earlier about the span of control. We also need to worry about something being overly complex. A situation where you've got so many different lines and bars and drawings, it's hard to tell what happened to your span of control. Or there might be so many things on there that it's really better suited to break it down into more logical groups. Maybe a separate threat model for this piece over here and another one for that piece over there, rather than having one big threat model that encompasses them all. It might be there's not enough trust boundaries. Could be that there's some sort of black hole process. This is where you have something where data goes in and never comes back out. Or a data store that, data lands in there and nothing ever uses it. And then there's an assumption that flows are omnidirectional. Single directional. In that they only go one way. And now, realistically, flows are often on the same channel, right? For HTTP, there's some sort of setup, and then it's sort of a bidirectional. But we're going to model those as just a unidirectional flow. A message starts at one point and goes to another. So now, I'm actually going to demo a tool that's available on the market. It's freely available for anybody. It's called the Microsoft Threat Modeling Tool. I'm going to show the 2016 version. There's also a new version that's a click once app that's just been available in the past month or so. It's mostly the same thing. Very little change there other than it's now an online, always up-to-date app. But it's really the best tool that we found to be able to solve this problem. There are other tools on the market that take different approaches. But for my world where I'm dealing with new product stuff that isn't done yet all the time, the tool that I'm going to show you is really the one that we found works best for us. But by all means, you should experiment with this. They're all going to work probably the same way. They're all going to have some sort of way to model how the things connect together, and then some sort of way to model what the threats to that might be. So let's take our earlier diagram and put that into a tool. So I'm actually going to take this diagram and draw it up, and it'll take me a few minutes here, but I'll talk people through it as we're doing it. So first I need to switch modes so you can see what I see. Okay, that's my slides. Come back to that. So here I have the tool. Just going to start with running it. I want to create a new model. I'll make this a little bigger. What was that? Oh, shoot, extended. Okay, hold on. Set to duplicate, just one moment. How about that? There we go. Okay, let me try that again. So, start the tool. We just want to create a model. And you can see it just starts with a blank canvas. You get a big design surface and a bunch of objects over here. So let me go back to my diagram here. We want to put this together. So we've got a web service in the middle. We've got a browser on one side. We've got some sort of administrator user on the other. We've got server storage on the bottom. So first we'll take something like a web server, which we have right here. Then we'll grab a browser and a human user and some sort of generic storage. It's always good to start to name your stuff. So what we will do here is just use the properties to change it. That'll be administrator. And what did we say that was? The web server storage. Okay, so now we need to wire stuff up. So we go to data flows. I'm going to start with some generic ones, and I'll show you how to convert. So we have a data flow that goes from the web server to the administrator. And we've got one that goes back the other way. And let's go back to our diagram. So we can see we've got authentication data, we've got page request, we've got two things going from there. I'll actually use the correct type on these. These are HTTP, got one that goes there. Another one that goes here. Oops. Okay, we don't want stuff to fall in a black hole, so we need to have data coming back out. And now we need to deal with that bottom part, how the data gets from the web server down to the web server storage. So for that, we'll just take, it'll probably be some sort of file. So not a perfect representation, but fairly close. Now we've got all of our objects on the same page. Now we can actually start to do some useful stuff like naming them. So in this case, we'll say this is authentication data. We'll leave the HTTP in there, but we'll say this is authentication data. And we've got a page request. And I'll do a couple more of these, and then I'll switch to the switch back. It'd probably be a little easier that way. Okay, so let me go back to that. So you can see in just a few minutes, we were able to create a diagram that's pretty close. We can all look at that and kind of nod our heads and say, yeah, that's what we built. Yep, that's how it works. Okay. Now, for the sake of brevity, we'll go over some other parts of it. But first, we're going to talk about, okay, so a diagram, now what? Well, great, you put a diagram together. Let's figure out what those threats are going to be. And so for each of those object types, we can look at the high-level technical types of threats. So for that external entity, we have to worry about spoofing or repudiation. For the process, we've got to worry about pretty much everything. For data stores, we need to do something like looking at how it might be tampered. Data flows have the same kinds of risks as a data store. And for a data store, one interesting thing is if it has logging data, then you have to be concerned about repudiation as well. But a trust boundary doesn't really have any threats. It's just a concept. It's something that helps you understand whether you need to worry about threats on either side of it. Okay, so we're going to take this diagram and start to identify the threats on it. So I have a demo here that's already pre-made. Just one moment. Here we go. So here I've taken all of those things from the previous diagram and I've mapped them all up, marked them up. And so now we can start to say, okay, well, let's start to figure out what those threats are. Maybe we have some extra ones we might consider. Some of those abuse cases, something a user might encounter where they get victimized, the man-in-the-middle types of attacks. Maybe some areas where we need to have logging. So let's go and look at some of those details in the actual tool. So we've got the model diagram. It's all built here. It's all mapped out. I'm going to use this as a starting point for some of the other parts. So here I've gone through, and for each of these objects, I've set the properties down in this corner. So I've said what it is, what it does. I've got detail around, in the case of, say, the tool certainly made for Windows, but you can kind of extrapolate. It's got things like what is it running as, what privilege level is it using. I've went through and set the properties. That'll help us get a more thorough set of threats out of the tool when it's all set and done. So let me switch to the diagram that has the model all set from just having it analyzed. So we built the diagram, we filled in the properties, and now we're going to go and say, well, I want to let the tool do some of the work for me. I want to see the analysis. You can see here, for every single one of the threats, or sorry, the object types, and the combinations of elements, it's built out a set of threats that go along with it. So you can see it's created a threat that's a tampering type for the data flow between the browser and the web app. Or it's created a repudiation threat from the browser to the web app. And you can even scroll down and look at different types. So let's say, well, where are all of our denial of service types ones? Okay, well, there's all the denial of service threats. And they're sorted by flow, so you can see as you scroll through the list here, it's going to show which ones are related to a particular flow. It gives you the chance to handle each of them on a different basis. And that's important because the kinds of things you might do to mitigate a threat in one area aren't necessarily the same kind of things you might do for another flow. Okay, so the tool, in this case, will generate it for you. It will analyze it for you for the basics. Now, you can certainly do all that yourself, right? If you go back to this earlier diagram here, you can manually map out things and do this entire process by hand if you want to. But a good tool makes it easy. But we're not quite done yet. We've gotten as far as building a diagram. We started to fill in the properties. Got it to analyze the tool, the design, and the tools put out a list for us. But now we need to go and finish the job and start to apply mitigations. We're going to use the tools interface. We're going to drop in details that help us understand, okay, here's how we're going to address that problem. So for each of these threats, we're going to look at, well, maybe we need to redesign something. We can apply standard mitigation for something like input validation. We might need to invent a new mitigation of some type if it's some new and unique particular thing. We might just say, well, we're going to accept that one. And that's okay. We're going to mark that in the tool. We want to make sure that it's a sin of commission, right? We know that that's what we want to do there. And then maybe one of the solutions might be to warn the users, right? Sometimes you just have to let the user know, hey, this is a risky adventure. Are you sure you want to format that hard drive? Right? That might be a threat you need to deal with. So let's go back and look at that in this pre-analysis, right? So now we can look at some threats. So let's take, I'm looking at specifically denial of service ones. Let's look at my favorites, elevation of privilege. So here we have something like, there's the ability of the web server to impersonate the browser to some degree. We might be able to have the browser try to remotely execute code. Might be something like cross-site request forgery. Okay, well, let's take this one. This is a classic web app problem. Somebody could somehow convince the user to click a link, and because that user's already logged in at the banking site, and the web app just trusts that the user knows what they're doing when they click on a link, it enables an attacker to, I don't know, send $1,000 somewhere, or buy a bunch of Bitcoin, or insert bad action here. So let's take this one, and we'll start to actually say, well, what are we going to do here? Okay, well, this one, we haven't started looking at it yet, so we got to figure out what we're going to do. And maybe we say, well, we look through, and for most of this app, there's only a few things that really matter. And you have to be authenticated. But for any time that you have an action that comes in out of the blue or is really particularly sensitive, like, say, changing a password, well, we'll make sure that we design it so that user must re-authenticate each time sensitive actions or privileged actions are taken. And you can see that same kind of approach in web apps today, right? If you go and change your password at a shopping site, they usually ask you to enter your old password before you can enter the new one. Or if you go and purchase something and you haven't logged in a while, they might ask you to re-authenticate before they complete the purchase. Now, we've got to go through and say, well, we're looking at this threat. We know what we're going to do. We're going to require them to re-authenticate, and that'll help. So maybe we have a couple of parts in here. But for this one, we're going to say, okay, that's our solution. But we haven't implemented that yet. So we need to investigate. And so we say that something like, well, okay, so that's the solution. But we need to describe what we're going to do to fix it. And if you're going to implement something, you need to have a basic test for it. So we need some test cases to check for that re-authentication once they're implemented. So right here, we've got a solution to the threat, at least to some degree. It's not implemented yet, but we know what we can do to fix it. And so we can just do that same kind of concept across everything. And there might be a few that are don't care. Well, the web server can impersonate the context of the browser. This might be not applicable, and that's because, well, accepted. The web server sends JavaScript to the browser. Okay, great. That might be how that part works. We've acknowledged it. We know that's the way it's going to be. Now we can say, okay, well, this one is not applicable. And, well, yeah, that's an accepted risk, so we think that's low. There's no perfect rubric here. The tool is going to default to not investigated, not started, sorry, and high priority. But you just leverage the capability of this here to track what it is you're going to do. So you've gone through these different threats, and now you've got a record that you can look at later on. Okay, so the process goes through largely the same way for the rest of them. And you can see in this particular case, just with this simple diagram, there are 52 different threats. So I'm not going to run through all 52. Let me just do a couple more examples, just to kind of show how you can leverage the settings in the tool to look at it a couple different ways. So obviously we have not started is what we haven't really looked at, but when we talked about needs investigation. But what about one that's just mitigated, right? So let's find one. A good example there that might already be mitigated is a category of information disclosure. Okay, so maybe we say, well, sure, the administrator, the configuration data he's sending could be tampered along that flow. Okay, but we can say that's mitigated because IPsec is used for communications. And the remote desktop protocol uses TLS. So you've got a couple different layers there. So you see that one it's not that it's not applicable, it's just that it's already been accounted for. And test cases in place to make sure that's the default. Okay, so there we have it. Put some detail in there. You say that's now medium risk because we've got to make sure that we default that way. We're going to make sure we go back and check it. And now we've just taken care of that threat. So we can say, well, if we're looking at ones that we haven't started yet, we've already got a couple, 4 of them already knocked out here. The tool also lets you sort. You can see you can kind of filter here. It's especially handy if you're working on a big grouping to say, okay, what's not done yet? What have we not even looked at yet? Well, the tool will help you find that just with some simple searching. Okay, so what does it look like when you've done the entire thing? Well, I'll show that in a moment. Let me get back to my slides here. So we talked about applying those mitigations to each of the threats as they've come up. Okay, we can do those different things with those threats. I gave you a demo on the mitigations. I'm going to talk through this, but it's good to recover. Once you're going through that diagram, you've got everybody in agreement that that's what the diagram looks like. Well, now we can go through and validate stuff. Okay. Have we gone through all the different threats? Do we have all of our follow-up actions created? Right. We did it. We went through the tool. We answered the questions. We've got all 52 of them filled out. Do we know what we're going to do with each of those? Do the needs investigated ones, those ones that are going to be investigated, have a follow-up owner? Does the test team know that they've got test cases incoming? We scheduled some sort of follow-up meeting. We've got a backlog to confirm that whether we've got features booked for certain mitigations, and we've got all of that post-implementation stuff scheduled to come back around and review again. Okay. What about assuring that? Well, we can confirm the changes once they're implemented. We can go back and actually sort of validate our threat model and ensure that we've got the things that we planned in place by looking for all those action items. Right? A good threat model drives further work, which is kind of ironic, but that's the point, right? We can go back and make sure we have those test cases in place, that we've tested for the effectiveness. Right? We've got tools, we've got subject matter experts. So when we say something like this is the default, there's a test case or a tool that confirms that is the default. Or we've got something like a penetration test where a qualified person who has some experience there goes and looks at it and tests and says, hey, you forgot it right here. This one mitigation that you thought you had isn't there. Helps you get that assurance story down. You can also use it as evidence for other artifacts. How many of you ever worked on something that has a failure modes effect analysis? A couple of you? Okay, great. In the devices world, it's very common. But you can actually take some of the evidence and use it in other artifacts. Or you can say, hey, some of those things that we identified as part of the threat model actually turn into failure modes elsewhere. It also becomes guidance for your secure operations team, right? Think of that diagram where those trust boundaries are. Would be a good place to have firewalls, security technology that's going to analyze the traffic going to and from. So they kind of help you target where to put some of your security smarts. So, in conclusion, remember, an effective threat model is simple, it's unambiguous, it's sufficient depth to capture those key threats that are going to be important for your development team. It's going to be clear on the assumptions and the dependencies, on the folks involved. It's going to follow those actions and drive through those mitigations and then follow up later on as part of your development plan. It's going to be helpful in defining all of those test cases that you need that are going to mitigate all those threats. And importantly, it's a living document. You do it once to start, or maybe not at the start, but you do it once and then you keep it updated over time. As the app grows, as the software changes, the threat model should grow. And it might not grow all that much all at once, but it's going to grow and you should keep it up to date. It's not a one-time thing. I've talked a bit about some of the tool here. I'd be happy to also go over a couple of resources. So the preeminent book is Threat Modeling by Adam Shostak. How many of you have a copy of this book or read it? Yeah? It's a great book if you want to get into threat modeling. He covers it from somebody who's never done it before perspective, all the way up through advanced ways, different approaches, different ways to view a diagram, whether you should go visual or just written. He covers all of that and the bag of chips, and it's really a great resource if you're trying to get into threat modeling or want to take it to that next level. Also, there's a bunch of websites. The tool that I demonstrated today is my preferred. It's the Microsoft Threat Modeling Tool 2016 version. It's freely available. It is Windows only, but it's freely available to use. It's very Windows-centric. You can certainly map stuff into other languages, and it has the ability to create a template. So if you wanted to build something from scratch, you can create your own set of templates that do something. And in fact, here, relevant to the Detroit area, a consortium of people got together and built a threat model template for the Microsoft Threat Modeling Tool to cover automotive stuff. So there's a template set that covers things like CAN bus. And you can do the same thing for yourself if you want to. Of course, the security development lifecycle is a great resource, not just for those of you who might be building apps that are going to run on Windows or a Windows variant, but there's just great guidance about how to build secure product in general. We leverage it a lot, even though a lot of the teams I work with regularly don't use Windows. They're on all sorts of different platforms. And then OWASP has some great resources, things like threat risk modeling, their particular approach on how to deal with it. A lot of great people that who participated in putting that together, and it's another resource you can leverage. And I think, yeah, I'm all done. I guess we got extra time. I'm happy to take some questions. Mm-hmm. Okay, so I just want to paraphrase. How do you keep it effective and efficient when the threat modeling sessions kind of drag on and on and on and on? The best way I've seen is to, one, be honest going in to start. I mean, if you have a team that's never built a threat model before, doesn't have a whole lot of experience, you should probably book about 3 hours for it. Maybe not all at once, because their eyes are going to glaze over, they're going to want to keep going. But plan ahead for that. Just plan 3 different sessions or 2 sessions, and say, okay, we're sitting down, we're going to focus on this, and the goal for today is get the diagram down. Right? The goal for day 2 is get the properties set. And then the goal for day 3 is work on the threats. And so that'll get you, excuse me, that'll get you most of the way there. It's certainly right around that, okay, now what do we do with all those threats? It can kind of drag on, especially when you got a somewhat complicated diagram and you've got, I've seen 120 threats easily on a somewhat complex diagram. That's where I like to leverage the tool and go back and say, okay, all these ones that are not started, let's do those first. So get the team focused in on, okay, let's keep staring at the ones that we haven't even addressed. The other ones that we've already looked at, we can certainly go back and we can go and maybe double check our mitigations, or we say, hey, wow, we decided to do it differently for this threat, so we have to go back and fix it. That's good, but stay focused on the ones that aren't done yet. That'll help you get through and get to the end of all the blank threats. Mm-hmm. Yeah. So the question was, can you do it for other stuff? And yeah, I mean, I'll give you a live demo here. Start the tool. Create a model. I mean, what is a SCADA object? It's like an OS process or something, right? Oops. And you've got some sort of data flow. It's going to go to some sort of data store. You got some sort of way that data flows to it. Right? You just use the tool the same way. The tricky part, though, is going to be when you. Mm-hmm. Okay, I'm not sure I found the generic term in the tool. Mm-hmm. If there's not a comparable analog, yeah, go for the generic type, right? Because a SCADA sensor is a process. Down in the low bowels, it's got an input on one side that might be the electrical sensor. The network part goes out the other part, which is a data flow. It's got some sort of logic in it that does something based on the input from the sensor. So you can model it as a process. And in fact, what we're doing for some of the teams I'm working with, we're actually building our own internal use custom template. And our approach is to first say, well, what is the nearest analog for that thing that we want to model? This particular type of protocol is really similar to HTTP or HTTPS, right? So we say, well, it does everything that HTTPS would do conceptually. So we'll start with that as our base model. And so you can do the same thing if you wanted to build a custom template to make it specific to a sensor or an actuator or something like that. Mm-hmm. I don't have internet access here working to be able to demo, but yes, and here's how. So you asked about, is there community resources? The latest version of this particular tool is a Click Once app, because really what's under the covers here is a .NET app, right? I mean, that's pretty much what this is. So they made it online and then it will always update itself. At the same time, they created a GitHub site that has a contribution place where people can just add to it and they can just check in their own templates. So they're building a community resource of templates. People can go and edit the existing ones, check in new ones, and so yes, that cache of templates for SCADA or IoT type stuff is going to build over time. It may not be around yet. The only one that I know of personally is the automotive one, but I think it's just a matter of time before people start building their own custom templates. Yeah. If you searched on Microsoft Threat Modeling Tool templates, would probably pull it up. The new app is something like aka.ms/tmt preview. Sorry, I don't have the exact address there. Search on the Microsoft Threat Modeling Tool 2016. You'll either get this one or the latest version. Probably the latest version. The differences between the two file formats are all the same. It's mainly bug fix once app now, and they made template editing easier.
Are there any other threat modeling tools that you feel in competition with this on? Like C-Sponge was a project that was put together.
Yeah, they didn't go anywhere.
Huge tool, but yeah, no progress anymore. Anything else that you respect at all?
I'll try to be as diplomatic as I can to answer your question about what other tools. Yes, there are other tools on the market. One of which we actually looked at. It was much more enterprise IT centric. It was more around modeling the threats due to your infrastructure than it was about modeling something that's not yet built. The challenge that we had is we haven't built stuff yet, right? We're doing this at the design stage. I'm looking at vNext. So the fact that I can model the risks to my web server because Qualys tells me it's unpatched is uninteresting. I haven't gotten to the point of deploying a web server yet, right? So that tool, which will remain nameless, but you might be able to figure out what I'm referring to if you've seen it before, just didn't fit our needs. There is recently some other tool that is a bit more, best way to describe it is very similar to something I saw the Microsoft ACE team make like a decade ago, where you fill in some detail about the type of flow and what kind of data is flying across it, and it'll give you a bunch of suggested controls. That recently became available. We looked at the demo. I haven't gotten any farther with it than that. But honestly, this is the best tool I've seen, and it's free. Okay, well, thank you very much.